Okay guys, so we are done with ionic bonding. Now we start covalent bonding. So this you can write if you are fast, you can write, you can take note of the definition. Covalent bonding is a type of bonding that occurs between non-metals, and usually it involves the sharing of electrons between elements. Okay. So quickly without flipping that much, let's go and look at some examples. It's writing very bold. Okay, let us look at the bonding in water molecule. We also look at the bonding in ethanol. We also look at the bonding in what's the last example which is there? Okay, we may look at an example of bonding in okay. Sorry, this should be a thin, like that. A thin. Now, beginning with water, so we can tell that we have two hydrogen atoms or molecules and one oxygen atom. So now, you guys, I taught you how to write this electronic structure, just considering the outermost shells, right? I'm sure you are aware and you know. If you look at the first and second bit that we did ionic bonding. So here now, we're gonna be like some kind of profession where we'll be just showing you the outermost shells of electrons so that we are moving together. Okay, so when you look at the periodic table there, the atomic number for hydrogen is just 1. Okay? Then oxygen is in group 6. If you look at the periodic table, and it has the proton number of 8. So I will write it there. That one 8. Then hydrogen, we have 2 atoms of hydrogen like that. Now let us show bonding in water molecule. So we'll say this oxygen, since it's in group 8, I said the group number of an element is equal to its number of electrons in the outermost shell. Just looking at the group where the element is found, that same group number is equal to the number of electrons it occupies in the outermost shell. So this oxygen, we have said it's in group 6. Since it's in group 6, therefore it has 6 electrons in the outermost shell. So we are going to draw the oxygen molecule like that with 6 electrons. So I can draw it like this. I have 2, 4, 5 there, 6. Since this involves the sharing of electrons, I won't be putting them in pairs of 2 like that. There should be a part where the bonding should occur, where it's going to share the electrons with the hydrogen. Okay. Now hydrogen has only the mass number of 1 and the atomic number of 1. Therefore, hydrogen cannot balance with 8 electrons in its outermost shell. It balances in the first shell, where it will have only 2 electrons. Now, as you can see here, we have 2 hydrogen atoms, which means a single hydrogen here with 1 as its atomic number, and another hydrogen here with 1 as its atomic number. So we're going to bond these 2 hydrogen with an oxygen molecule atom. We are going to say, okay, this hydrogen here will bond. So this is oxygen, by the way. And we will bond to this hydrogen which is there. Then, so since they are sharing electrons, we are going to write them as this electron which was for oxygen which was here, I'll put it in between since they are sharing. And then this one, so we are bonding with this one with the oxygen. This electron here, the one for hydrogen, we are going to put it there as a dot. And we come to this other one. It will appear somewhere there, whereby we say the hydrogen there bonding that is in the water molecule. Now let us look at these things if they are balanced. Let us look at the number of electrons of oxygen in the outermost shell. So this one is in group 6, therefore it lacks 2 electrons to balance, and it has to balance with 8 electrons in its outermost shell. So we have 2, 4 here, you have to count even the one for hydrogen since they are sharing. So 4 here, 6, and then 8. So oxygen is balanced, and then for hydrogen, I said it will balance the electronic structure for hydrogen will balance the first shell, which is the first shell which occupies only 2 electrons in its outermost shell. So we have hydrogen there, then this one and this one makes it 2, then that one and that one makes it 2. So this is the correct electronic structure of the water molecule. This is ionic bonding. It just deals with nanometals, and the type of bonds which are present in this type of bonding are weakly intermolecular forces, since it's just between nanometals. When you go to ionic bonding, which involves the transfer of electrons from a metal to a nonmetal, which involves charges of different, which involves also different charges, which is positive from metal, negative from a nonmetal. The type of bonding or forces that bonds elements together there is strong intermolecular forces. Here it's weak intermolecular forces. Now let us look at how we